Our second page here has even and odd functions and then function notation. So here's our definitions. An even function has a graph that's symmetric to the y-axis. So here's an example of something that looks even. You would need to find the y-axis, the one that goes up and down, and make sure that the graph looks the same on the right that it does on the left of that. They would fold right on top of each other. So an odd function has a graph that's symmetric with respect to the origin. And it's actually not really symmetric, it's like a rotation. Symmetric is in the definition, but I like to say it's like you rotate 180 degrees about the origin. So remember, the origin means 0, 0. It's that point right in the middle of the graph. So if I were to take this piece of the graph and rotate it 180, it would go to the quadrant across from it and rotate up. So if you have a graph over here, say it's in this quadrant, it would rotate to the one across. That's why it's symmetric. It always goes across quadrants. That would be odd as well. So say you have a graph that doesn't meet either of those, then it would be neither. Okay, our last one, you're going to see function notation. So y equals f of x. You're going to see it the other way, f of x equals y, where the xy from that notation is an xy point on a graph. And I just have, this is from a sample problem that you're going to have to do today. So f of 0, you want to go to x equals 0 on the f of x graph. So the f of x is the parabola and g of x is the line. So if I go to x equals 0, that's the y-axis, there's a point here on both graphs actually, the 0, -5. So remember, f of x equals y. So if 0, f of 0 equals -5. These are going to make an xy point. Those match. That's how you do function notation. So here, g of 7. So I'm going to go to find x equals 7. So I'm going to the x-axis, x equals 7. Now I need to go to the g graph, which is the straight line. So up, I'm going to follow up x equals 7 all the way up here. And the y value is 6, 7, 8, 9. So g of 7 equals 9. The two numbers that you're showing need to be the two numbers on an actual point on the graph. So f of x equals g of x. This is where the x values are the same, which means that's at an intersection. And we already saw one of those, right? This very first point, that point's the same on both graphs. X is 0. But there's another point right here where x is 4. I'm going to write the y value, even though we don't need it. We're just looking for x. So now we're given f of x times g of x equals 0. So this is the y value is 0. So that's at the x-axis. So where points for f of x and g of x is 0. So that's x equals 1, that's 2.5, and that's 5. Okay, next one. Now we have to find multiple values. We have to find f of 6 and g of 6. So we're going to go to x equals 6 on our graph, and we want the values for both graphs. So here's x equals 6. We're going to go up and down. We got to go find both graphs. So what are the y values there? That's 7, and that is -5. So on F, that's the parabola, we have -5. And on G, we have 7. But look, we want to add those values. We're going -5 plus 7, which is 2. We're going to do that same thing again, f of 5 minus g of 5, but now we got to go find out what's x equals 5. What's the y value? So again, I like to go to the x-axis, go to 5, and then go find the graph. Oh, I'm right here. It's hard to see. They're all overlapping. Well, one of them is right on the axis, 5, 0, perfect. That's on f of x. So 5, 0 is my point. So that means f of 5 is 0. And then g of 5 is 5, 5, 5. That's the point. So we're going to take 0 minus 5, which is -5. Okay, so it's just being able to go back and forth from the graph to function notation.